Alright, this video is just a review of piecewise functions. And the first example is obviously an application problem and a little more challenging than the second example that I'll do. So if you read through it, it says a plane descends from 5,000 feet at 250 feet per minute for 6 minutes. Over the next 8 minutes, it descends at 150 feet per minute. Write a piecewise function for the altitude A in terms of the time t. So in other words, the height of the plane is dependent on how long or how much time it's in the air. So I know I'm going to do a piecewise function. I know it's going to be altitude in terms of time, so A sub t. And it looks like I just have two pieces, and I know that because I have two different rates here. I have a descension of 250 feet per minute, and then later on it's slowing down to a descension of 150 feet per minute. So I'm going to start, and I'll use two different colors so you can kind of follow. The first one says, it descends from 5,000 feet at a rate of 250 feet per minute. So 5,000 feet is like the y-intercept, so that would be the starting point. And then it's descending, which means it's going down, so negative 250 feet per minute, so times t. So whatever time I put in for here, up to 6 minutes of course, times negative 250 since I'm descending, and then plus the 5,000 where it started, will tell you what altitude that plane is at. Now the constraint is that this happens for 6 minutes, so that means time has to be less than or equal to 6. Now one error I see often is that people forget to say that also has to be greater than or equal to 0, and I know that's an obvious situation, time can't be negative, but in math we have to write that obviousness that we think of. Alright, the second piece, I'll use a different color, says over the next 8 minutes it descends at a rate of 150 feet per minute. So we don't know where it's starting at that next 8 minutes, but we do know that the next 8-minute increments start after the 6 minutes is done. So down at the bottom, I'm going to take that first piecewise function, 250t, but I'm going to substitute time with 6 because at the 6th minute is where this descension rate changes. So I've got to know what that is. So A sub 6, or the altitude at 6 minutes, is 3,500 feet if you do that simple math. So that's going to be my y-intercept of the second piece. Actually, I'm going to erase this and make a little more room. Of my second piece here. And it's descending at a rate of negative 150, but now I can't just do time. Because if I do, let's say I'm flying for 10 minutes, the first 6 minutes of those 10 are going to go in this first piece, right? And then after that, the last 4 minutes of the 10 are going to go down in this piece. So how do I represent that? Well, my time has to be subtracted from 6. So again, if I was flying for 10 minutes, 10 minus 6 is 4. So those 4 minutes are going to be in this piece, and the first 6 minutes will be in the red piece. Okay, and that time constraint is anything beyond 6 minutes, so I really can just do t is greater than 6. And that's everything. Those are your two pieces. Alright, this one is a little more basic. You have a nice linear piecewise function, so I will again use kind of two different colors here. So this first one is negative x plus 1, but only graphing that linear line for x values less than or equal to 2. So first of all, I'm going to start with the equation. Well, I know the y-intercept's at 1, and I know the slope is negative 1, so that's fairly easy. Y-intercept is at 1, slope is negative 1, so down 1 to the right 1. Or I could go up 1 to the left 1. Fairly straightforward, but I'm not going to draw the line because I know that the constraint is only for x values that are less than or equal to 2. Well, less than or equal to 2, here is where it hits 2. I'm going to kind of highlight that point. And anything less than or equal to that would be all of this, but not these points. So I'm going to erase those. So again, that, and don't draw this line in, but I mean, x equals 2, would be like right here. That's kind of that cutoff line there. And I want my line to be everything less than or equal to 2. So inclusive of 2, everything less than that. Then the second line, and I'll use a different color for that one, is a nice horizontal line, y equals -1, so that's just going to be a nice horizontal line, but only graph for x values greater than 2. So here's y equals -1, but I only want it to be greater than this -2 boundary line. So -2 greater than that would be all of this. I don't want to include the 2. However, it's being included in the green line, and obviously you won't be probably using 2 different colors, so you can't really show that, and that's okay. So I'll just put an open circle there, and then it's everything to the right. Now there's no solid or dashed lines. Remember, these constraints are open and closed circles. Now again, it's closed for the green line, but open for the orange line. And if I didn't have 2 different colors, I really wouldn't know which one, it's open and closed for. But if I have the functions in front of me, I can see it's closed here, open here. So, that's fine. So if I said find f of 2, you would know to go to this equation because it's not equal to 2 in the second equation. So you would do -2 plus 1. So f of 2 is equal to -1, which you can also see that point on your graph is the point 2, -1.